so this is going to be Unit 3 in Mod 5 Topic 2, where we talk about factorials, permutations, combinations to find different types of outcomes. Okay, so in 1808, Christian Cramp introduced the factorial, which could help you perform some calculations in the previous activity. The factorial of n, which is written with an exclamation mark as n factorial, is the product of all non-negative integers less than or equal to n. For example, 3 factorial is 3 times 2 times 1. Okay, so if I was writing this, I would write 5 times 4 times 3 times 2 times 1. So whatever number it is, you kind of descend off of it. Okay, and then in your calculator, you could type 5 times 4 times 3 times 2 times 1. And you can get 120. Next one, I'm going to descend off 7. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Which is 5,040. Okay, if you didn't want to descend all the way down and do 10 times 9 times 8 times 7 times 6, okay, or write it all out, if you actually press the number first, so like this one, I would type in 10, I'd press my math button, I'd go over to where it says PROB or PRO depending on your calculator, and then there's actually an exclamation point in that math section to give me my answer for the next one, which is 3628800. So you go to the math section, you scroll over using your arrow button to the PRO or PROB, and then scroll down to your exclamation point, okay, your factorial. Make sure you type the number first so it actually works, and it is the little shortcut. Okay, so Khalees says that 10 factorial divided by 5 factorial is 2 factorial because 10 divided by 5 is 2. Is she correct? So if I wrote this out the long way, I'd have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Multiplication signs in between all of these. All over 5 times 4 times 3 times 2 times 1. So if you actually think about this, 1 divided by 1 is 1. 2 divided by 2 is 2. So if you have the same thing on top and same thing on bottom, you can actually cancel them. So because I have a 1 and a 1, that's a 1. 2 divided by 2 is 1. 3 divided by 3, 4 divided by 4, 5 divided by 5. So really what I have left is 10 times 9 times 8 times 7 times 6, which is not the same thing as 2. Because if I type it in, 30240 does not equal 2 factorial, which is 2 times 1, which is 2. It says write each expression as a ratio of 2 factorials. Okay, so I need to somehow, let's pretend I wanted 2 and 1 in here. Well, that's going to be 5 factorial. Because 5 times 4 times 3 times 2 times 1. Well, if I want to take the 2 times 1 off, or if I canceled, if I throw a 2 factorial on here, that's the same as if I wrote it out the long way and I canceled 2 and 1, which is what's left. So this one I need 7 factorial. I want to take off 3, 2, 1, so I can divide by 3 factorial. Okay, which is the worked out example right here. Same thing on top, same thing on the bottom. I can divide and get 1. So determine each value. So I want you to write these out the long way and do cancel to get your answers and multiply what's left. Okay, so what I'm going to do is I would recommend pausing the video and writing them out and doing your crossing off to find out your answers. I'm going to do it very quickly and then replay. Alright, so the one that people generally struggle with is this one down here. So you just make sure you descend off 7 and then multiply descending off 5 on the top, descend off 8, and then multiply the descending off of 3. And then you can cancel the exact same numbers on top and bottom. Okay, so using factorials, rewrite your answers to the following questions. Okay, we're going to skip this one. So how many different 4-letter strings can you make using the first 4 letters of the alphabet? So 4 factorial, type it in your calculator, and then we got 10 letters, so 10 factorial. So if I type in 4, go to math, PROB, scroll down to my factorial, this is 24, then do the same thing with 10. Three, 6, 2, 8, 8, 0, 0, 0. Okay, so permutations. An ordered arrangement of items without repetition is called a permutation. Okay, so the most common ways you will probably see it are these two ways. So permutation, order matters. That's the big thing with this. Okay, so examples of ordering mattering: if you're assigned president, vice president, and secretary, the order is going to matter in that. If you are getting first place, second place, or third place, first place is better than third place. Okay, so if you're assigning certain things, or if you are doing a code, then the order is going to matter. Okay, so it says, suppose you form 2-letter strings from the first 4 letters of the alphabet. How many choices are there for your first letter and then your second letter? Okay, so how many total? There are 4, and then we are choosing 2 of them. So in the next page, we're going to talk about how to actually type it in. So this is our formula. So N is always going to be your total, and then R is going to be what you choose. Most of the time, the total is always going to be bigger than what you actually choose. So just realize the bigger number will always go on the left. Okay, so if this is my N, this is my R, I'm going to fill it into my equation. So I've got 6 factorial over 6 minus 3 factorial. Well, 6 minus 3 on the bottom there is 3, and we know how to work this. Okay, so I can even type it in my calculator, do 6 math PROB, go down to my factorial, and then divide by 3 PROB factorial and get 120. Okay, so we can type it in that way, or instead of doing the whole long process, we actually have this button in our calculator. So what you're going to type in is you're going to type in 10, go to your math, go to your PROB, scroll down, and there's an NPR button, and then you have to make sure you type in 1 before you press enter twice. So it should look like that, and you should get 10. So if you try your next one here, if you do 5 math PROB, scroll down to the one that says NPR, click 2, press enter, you're going to get 20. So we don't even have to do the long mess. The calculator can do it for us. Okay, so a Sunday shop sells yogurt sundaes with 2 layers, 4 layers, or 5 layers of yogurt flavors. The shop carries 65 flavors in all. How many different 4-layer sundaes could you create without repeating flavors? So there's a total of 65, and we are choosing 4 of them in this one. So 65, choose 4. So 65, go to my PROB, and we are choosing 4. So there are this many ways I could top my ice cream. Which type of sundae would give you the greatest number of choices? Well, we already did 4, so I now need to check 2 and 5 to see which one's going to give me the biggest. So 2, I got 4, 1, 6, 0, so most likely 5 is going to work for me. So 5 is going to give me the most choices out of all 3. Okay, a briefcase has a lock. Anytime we're coding or locking something, that order matters, because if I'm trying to unlock the code, I need to have the right password. So a briefcase lock has 3 dials, each with the digits 0 through 9. The 3-digit code that unlocks the briefcase has no digits repeating. If you tried one code every 5 seconds, what is the greatest amount of time you could spend to open the briefcase? Okay, so total numbers, there's 10 digits. So 10, and I am choosing 3 of them. So there are 720 ways. You can multiply it times 5, and you would get how much time it could take you to open the briefcase. Okay, so permutations with repeated. Okay, repeated because if I flip-flop S here, it means the exact same thing. So there's kind of 2 different ways to do permutations. The order matters in this because otherwise it's not going to spell the same word. Okay, so there's 2 different ways to do it. One way you could do it is there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So you could say 8 letters total, and I need to choose all 11 of them to be able to make this word. And then what we're going to put on the bottom is all the repeated. So I see I repeating 1, 2, 3, 4 times. So that's my 4 factorial. So that's my I representation. I see 4 S's. So I'm going to say 4 factorial for all those S's. And then I see 2 P's. So I'm going to say 2 factorial for those 2 P's. Okay, when you go to type this in your calculator, you have to use parentheses to say that those are together in the bottom. Okay, let's say you didn't want to do 8 choose 11 or 11 choose 11 on top. The other thing that you could have written on top here is just 11 factorial. Okay, so if we go ahead and type that in, and we make sure we use parentheses for the bottom, we get 34650. Okay, so choose your way of doing, well, I'll do the next one here. Okay, so we could do 1, 2, 3, 4, 5, 6, 7, 8, choose 8 on top, and then I see 2 A's, and then I see 3 L's. I make sure I use parentheses when I type it in my calculator. And I get this. So go ahead and try the other two, and then I'm going to go through them in the video very quickly. Okay, those are the answers that you should have gotten. You could have had 5 choose 5 up here and 5 choose 5 again, so 5p5 and 5p5. Okay, so you can also have repeated elements outside of just letters. So if there are 4 chocolate chip cookies, 2 oatmeal cookies, and 2 double chocolate cookies in a box, how many different orders is it possible to eat all of the cookies? So first we need the total, so 4, 5, 6, 7, 8. So we could have 8 factorial on top. We have 4 chocolate chips repeating, we have 2 oatmeals repeating, and we have 2 double chocolate repeating. And then we're going to type it in our calculator. We get 420 outcomes. Okay, so just realize it's not always letters that repeat. If you see items repeating too, that can also work that way. Okay, so you can go ahead and try the mathematics. I'm going to go ahead and go to circular permutations. Okay, so we have been doing linear, so they've been written in a line. Okay, that's my normal 6 factorial. We can also have them circular. Okay, so if we look at this circular, I can technically rotate all of these one spot, and that is a new outcome. So my formula for this is n minus 1 factorial. To represent that I can move it one spot, and that's a new outcome of writing my numbers in a circle. Okay, so in how many different ways can 6 people be seated at a round table? So I can rotate in one spot, so 6 minus 1 factorial, which is really 5 factorial, which is 120. Okay, I want you to go ahead and try the other 2 there, and I'm going to write out the answers. Okay, and those are your answers. That should be a 120 down there. Okay, so we did permutations where order matters. Combinations, order doesn't matter. Okay, an example of this is if I had 20 people in my classroom and I sent 5 of them to the office, it doesn't matter what order the 5 walk to the office in, as long as all of them make it to the office. I'm not assigning certain roles. As long as they all make it there, it's fine. Okay, so the n and the r are going to be the same thing, so this is going to be my total, and this is what I choose. Okay, the big way here, we're going to test it out and do what our calculator is going to do. Okay, so this is my n, this is my r, so if I plop it in there, I've got 6 factorial over 6 minus 3 factorial times 3 factorial. So if I simplify it in my parentheses, I've got this getting me to 3 factorial with still my other 3 factorial. We can type it in using parentheses in the bottom. And I get my answer is 20. Okay, but we also have the cheat. So my next one here, type in 10, press math, go to your PROB section. Instead of NPR, you're going to use NCR, type in 1, and you're going to get your answer is 10. Okay, this one is N over R, or just remember, the bigger number should always be on the right if you have a choice. Okay, so you're going to type in 7, go to your math, your PROB, your NCR, because we're doing a combination, type in 3, and you should get 35. Okay, so use an organization of 10 members in the formula for combinations to answer each question. How many 4-member committees can be chosen? So how many total members, because remember that always goes on the left, and then we are choosing 4. Okay, this one we have a total of 10 and we are choosing 6. This one we have a total of 10 and we are choosing 10. So go ahead and type these in, pause the video, and I'm going to put the answers up. Okay, so weirdly enough, if I have 4 members or 6 members, it's the same amount of outcomes to make committees. Okay, so a computer code uses 4 randomly selected letters of the alphabet. If no letters are repeated, how many possible codes are there? Okay, so I'm coding. So because I'm coding, it's going to be a permutation. All right, so total amount, we've got 26 letters in the alphabet we can choose from. I'm coding, so it needs to be a permutation, and I'm picking 4 of them. Okay, so what I'm going to do is you can type it in your calculator. I'm going to just go ahead and go through permutation combinations and what they are. Okay, so my next one, 12 students are competing in the finals of a spelling bee. The top 3 finishers are awarded a gold, silver, and bronze medal. And how many ways can the medals be won? So I just assigned something, so the order is going to matter. Okay, so there are a total of 12, and I am assigning 3. Okay, my next one is summer camp offers 12 different afternoon activities. Caleb selects 2 of the activities to do today. How many possible outcomes are there if the order of the activity is important? So it just said the order is important, so I have to do permutation. There are 12 and he's choosing 2. Otherwise the order wouldn't matter and we do a combination. Okay. There are 15 different seminars at a teacher's convention. Mrs. Alvarez will choose 3 of the seminars to attend today. How many possible outcomes are there if the order of the seminars is important? Just told me it was important, which told me he's a permutation. So 15, choose 3. A committee of 4 students is to be formed for a homeroom of 25 students. How many different committees are possible? It doesn't matter what order they're assigned in, so it's going to be a combination. A pizzeria offers 8 different toppings on their pizzas. If a customer wants to order a 3-topping pizza, how many possible options are there? Does it matter what order I put the toppings? To some people, maybe. Okay, but it doesn't in this situation, so 8, choose the 3 toppings. 7 friends are playing musical chairs in the first round. There are 5 chairs, so only 5 of the friends will move on to the second round. How many different groups of friends are possible for the second round of the game? Okay, does the order of where you sit matter? No. You just need to make sure you're sitting on the chair to be able to go to the next round. So there's 7 friends, and we are choosing 5 of them to go to the next round.